Now we are going to discuss hydrocarbons. So what is hydrocarbons? Means the molecule contained with only hydrogen and carbon, that we can say as the hydrocarbons. See, hydro means only hydrogen, carbon, hydrogen and carbon. The compounds containing only hydrogen and carbon, those can be called as hydrocarbons. This can be further classified into the two types. One is the open chain hydrocarbons and a closed chain hydrocarbons. Open chain means it is in the straight chain or branched chain. These are also called as aliphatic or acyclic hydrocarbons. The next one is closed chain, means it is in the form of a ring. It is in the form of ring. Ring hydrocarbons also we can see. See the example. These three carbons are in the form of ring, a closed. This we can say is a closed chain of hydrocarbons. The hydrocarbons are based on the bond nature. This can be further classified into the three types based on the bond nature. And between of carbon to carbon, what are the bond present? Based on that, these are further classified into the three types. One is alkenes. If the carbon to carbon only single bond, it is a present of only single bonds, those can be named as alkenes. If the carbon to carbon double bond in the carbon chain, if you take the any longest chain or smallest chain also, in that between the two carbons, at least one double bond is present, those can be named as alkenes. If carbon to carbon, at least one triple bond, carbon to carbon, at least one triple bond is present, those hydrocarbons can be named as alkynes. In this, the hydrocarbons are classified into the alkenes. These two can be said as unsaturated hydrocarbons. Unsaturated hydrocarbons. These alkanes can be named as saturated hydrocarbons. Saturated hydrocarbons. So we can say again, hydrocarbons is nothing but the hydrogen and carbon will be present in that molecule. This can be classified into the two types: open chain hydrocarbons, closed chain hydrocarbons. Open chain hydrocarbons are maybe in the straight chain or branched chain. Based on the bond nature, hydrocarbons are classified into the two types: saturated and unsaturated. Saturated is nothing but carbon to carbon, only single bonds will be present. In the alkenes, the unsaturated is classified into the alkenes and alkynes. In the alkenes, carbon to carbon at least one double bond. The carbon to carbon at least one triple bond will present. Those are categorized into the alkynes. Now, isomerism. So, what is isomerism? So, same molecular formula but different in structures. So, structure difference, there is a structural isomers. If it is a functional group is different, functional isomers. If the position is different, positional isomers. But only one thing, the major concept here, molecular formula should be same, but it is differs in position or structure or functional group. So those are all can be called as isomers. This phenomena can be called as isomerism. So let me check with one example. So I wrote here CH3, CH2, CH2, CH3. So how many number of carbons here? 1, 2, 3, 4. Total 4 carbons. Right. Number of hydrogens 3, 4, 5, 6, 7, 8, 9, 10. So total number of hydrogens is 10. So in this molecule, in this structure, the total number of carbons is 4 and number of hydrogens is 10. Check in this structure also. So 1, 2, 3, 4. 4 carbons, right? C4. How many hydrogens? 3 plus 3, 6 plus 3, 9 plus 1, 10. C4H10. So it is also having the C4H10. It is also having the C4H10. So molecular formula should be same, but differs in the chain. See, this is the straight chain and this is a branched chain. So what is the name of this compound? So total number of carbons is 4. So we can write but, all the single bonds. So we can write A. So butane. For this 1, 2, 3. Its second carbon, it is having the methyl group. So 2 methyl. 2 methyl. Total straight chain having the carbons is 3. So we can write pro, all the single bonds. So we can write A. So 2 methyl propane. and another one is butane. See, the names is different and the structure or position is different, but the molecular formula is same. So this we can say as the isomers. Let us check with next example. So total number of carbons. So total number of carbons you can see here 1, 2, 3, 4, 5. Total number of carbons is 5. So C5. How many number of hydrogens? 3 plus 2, 5 plus 2, 7 plus 2, 9 plus 3, 12. C5H12. The given compound is C5H12. So what is the name of this compound? Total number of 5 carbons. So we can say as a pent, all the single bonds A. So we can write pentane. Right. Check with this structure. Total number of carbons is 5. Total number of carbons is 5. So C5. See, 1, 2, 3, 4, and this is a 5. Right, number of hydrogens 3 plus 3, 6 plus 1, 7 plus 2, 9 plus 3, 12. So C5H12. So this structure also having the number of carbons is 5, number of hydrogens is 12. So both are the same molecular formula, but differs in the structure. It is having the straight chain, it is in the branched chain. So second carbon having the methyl group, so we can write the name of 2 methyl. 2 methyl. So longest chain is 4. So that is a but. All the single bonds A. And next, if the second carbon having a methyl group, second carbon having the 2 methyl groups, that we can say as the position of iso. When you are saying the iso position, then you have to count the total number of carbons. So that is a pentane. Isopentane. The other name of 2-methylbutane is isopentane. Right. Next, check in this structure. So 1, 2, 3, and 4, 5. Total number of carbons is here also 5. Hydrogens you can see 4 3s are 12. So C5H12. It is also molecular formula having C5H12. So what is the name of this compound? So second carbon having the 2 methyl groups. So we can write 2 comma 2 dimethyl. 2 comma 2 dimethyl. So total number of straight chain having the carbons is 3. So that we can say as the propane. Pro-A. If the second carbon having 3 methyl groups, that we can say as the neo position. Then total number of carbons is 5. So we can say as a neopenta A. Neopentane. That other name of neopentane is 2 comma 2 dimethyl propane. It's having the molecular formula is C5H12. Similar molecular formula of other name is other structure is 2-methyl butane, or we can say isopentane. Generally pentane. So these three are belongs to the isomers of C5H12. These two are the isomers of C4H10. So in this, what you are identifying here, same molecular formula but different in the structures. This we can say as the isomerism. Next, try with another example, C6H14. So, video pause facing. What are the possible isomer structures of C6H14? You have to try it. Pause the video and try it. So first, general structure. 6 carbons, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 carbons. So possible of hydrogens is every carbon must be bond with 4 bonds. So CH3, CH2, 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 CH3. Total hydrogens 3 plus 2, 5, 7, 9, 11, 14. So this is a possible of structure. Next, CH3, CH, CH3, one branch I am taking. So CH2, CH2, CH3. 1, 2, 3, 4, 5. Plus 1, 6 carbons. So here number of carbons is 1, 2, 3, 4, 5. In the longest chain I am taking the 5 with one branch. So what is the name of this compound? At second carbon there is a methyl group, so we can write iso. Total number of carbon 6. It is hexane. Isohexane. So what is the name of first compound? Hexane. Next, what is the possible here? At second position it is there, so you can change the position. So CH3, CH2, CH, CH3, CH2, CH3. So check the numbering. So 1, 2, 3, 4, 5. You can see in the first, the previous, in this diagram, in the structure, there is a second carbon, there is a branch is there. But in this structure, there is a third carbon having a branch. This two we can say as the positional isomers. This two we can say as the positional isomers. So what is the name of this structure? Third carbon having the methyl group. So 3 methyl, 3 methyl, 5 carbons. So pent, A, 3-methyl pentane. This is also called, what is the other name of the structure? Its second carbon methyl group is there. So 2-methyl pentane. 2-methyl pentane. Next, any possible? See, 5-member chain. Then reduce the one carbon. Reduce the one carbon. So CH3, C, CH2, CH3. So first I was taking the 6 carbons, then it is a 5, at position changed, then I reduced to 4. This is the CH3 and CH3. Count the hydrogens: 3, 6, 9, 12 plus 2, 14. Here also 3 plus 2, 5, 6, 7, 8, 9, 10, 11 plus 3, 14. Right. So however you are getting the 14 hydrogens, 6 carbons. What is the numbering? 2, 3, 4. What is the name of this compound? So actually second carbon having the 3 methyl groups. So this we can say as a neo position. Neo hexane. What is IU5? At second position having the 2 methyl groups. So we can write 2, 2 dimethyl, 2, 2 dimethyl, 4 carbons. 4 carbons means but. All the single bonds A. So this is a possible isomers. Possible isomers. Is there any another possibility? Right. Let me check here. CH3. 4 carbons I am taking. The 2 branches I am taking. So 3, 6, 9, 12. Here the only 3 bonds is completed. So 1 hydrogen. Here the 3 bonds completed. 1 hydrogen. Total 14. So how many number of carbons in the longest chain? 1, 2, 3, 4. 4 carbons with the 2 branches. So what is the name of this compound? Sir, its second carbon is a 2-methyl, but it is also having the methyl, so we should not say this is the iso position. So we can write general nomenclature, that is 2, 3 dimethyl, 2, 3 dimethyl. At second position methyl group, third position methyl group. So that we can note 2, 3 dimethyl. So longest chain 4. So that is but. All the single bonds A. So 2, 3 dimethyl butane. For the C6H14, the possible isomers: hexane, isohexane, neohexane, 3-methyl pentane, and 2, 3 dimethyl butane. So these are the possible isomers of C6H14. Now we can see some chemical reactions, the chemical properties of carbon compounds. Actually, carbon will forms the millions of the compounds. So in that, some of the compounds can be react. So it is very limited only. So in that limited, how it will be involved or how it will be participated into the reactions. So in that, some of we wrote here: combustion reactions, addition reactions, oxidation, and substitution reactions. So first, what is the combustion reaction? Combustion is nothing but presence of oxygen. We have to heat that compound. Right. See here, carbon and its compounds burn in presence of oxygen or air. In presence of air, that must to be heated. So in this, they can liberate some heat and energy along with the carbon dioxide gas also liberates, because all the carbonate compounds will having the carbon. So when it is reacting with oxygen, it must be liberates the CO2, carbon dioxide. Next, this is the burning process. So it will be liberates the heat and light. So see the some examples. If the only carbon is reacting with oxygen, CO2. There is a CH4, CO2 and H2O, C2H6, CO2 and H2O. Along with that, it will liberates the energy. If any chemical reaction liberates the energy, those type of the reaction we can say as the exothermic reaction. So all the combustion reactions are the exothermic reactions. Okay, next. Already we discussed some of carbon compounds. Hydrocarbons are saturated and unsaturated. If the saturated compounds are burning process, they will use the clear light with the blue film. If it is unsaturated hydrocarbons, they can use the sooty flame of yellow color. So sooty flame means it is a black color. Little bit the vessels can having a black color. So that we can say is the sooty flame. Means the supply of the oxygen will not be 100%. When it is a burning process, the 100% of oxygen will not be supplied. This is applicable to the saturated hydrocarbons also. If you are burning the saturated hydrocarbon, the supplying of oxygen little bit if it is any difficult to supply of that. So that is also will form the sooty flame. So maximum all the aromatic compounds can be forms the sooty flame with the yellow color light. So this is regarding combustion reactions. Next, oxidation reactions. In the types of reactions, the second one is oxidation reactions. So, what is the definition? So, it may be carried out using the oxidizing agents. So, what is the oxidation? Oxidation is nothing but addition of the oxygen or removal of the hydrogen. Okay, we have to use the oxidants to convert into the or supply of oxygen. We have to addition to the oxygen or remove the hydrogens. So I am taking the example of ethanol. So CH3, CH2, OH, ethyl alcohol. So in this number of hydrogens is 6, 1 oxygen it will be present. So this we have to use the oxidant, the oxidizing agent we are taking as a alkaline KMnO4 or acidified potassium dichromate. So these two can use supplying of oxygen and it will generate the more oxygen supply to this compound. So it can be converted into the ethanol or acetaldehyde. See here CH3 CHO. How many hydrogens you have? 3 plus 2 5 plus 1 6. But here the 4 hydrogen. Okay? Removal of hydrogen is done in the first step. Further it will be carry forward that process. It can be converted into the ethanoic acid or simply we can say acetic acid. You can see improvement of oxygen will be there. The addition of oxygen generated. First it is having the single oxygen continuously processed in presence of this two, it is converted into the acid. So this we can say as the oxidation reaction. Simply we can say alcohol can be converted into the aldehyde. Further process it is converted into the acids. That process can be called as oxidation reactions. Here the one question, combustion reaction also once you can check carbon plus oxygen it is converted into CO2. So here addition of oxygen is done. So it is also oxidation reaction. All the combustion reactions are oxidation reactions but not all the oxidations are combustion reactions. అంటే అన్ని ఆక్సిడేషన్ రియాక్షన్స్ అన్నీ కూడా combustion reactions కావాల్సినటువంటి అవసరం లేదు because of in that heat will be generated but there is no heat generation so that all the combustion reactions are the oxidation reactions but not vice versa. Okay, so this is the oxidation reactions. The chemical properties of carbon and compounds. Third type of reaction is addition reactions. So what is addition reactions? Unsaturated hydrocarbons are converted into the saturated hydrocarbons. So here addition of hydrogen will be done to the unsaturated hydrocarbons. They are attaching with one and one hydrogen. They are converted into the saturated hydrocarbons. It must be presence of a catalyst. So what is a catalyst here? So catalyst is nothing but it will not involve in any chemical reaction but it will increase the rate of reaction. Some catalyst can be increase the reaction, some catalyst may be decreases the reactions. So here the catalyst means which regulates the rate of reactions. So see the example, but-2-ine. This is an unsaturated hydrocarbon. So triple bond is it. In presence of nickel, we are reacting with the hydrogen. So the hydrogen bond will break. One hydrogen will attach with one carbon, another hydrogen also will attach with one carbon. Here the bond will be break here, triple bond. Then that radicals will be formed. Then they can attach with one hydrogen. So this further continuously react. Then in the presence of nickel, the another hydrogen molecule we are reacting with but-2-ene. Here also the double bond will be break, and this hydrogen also will attach with one carbon, and it can be forms into the but-ane. Unsaturated hydrocarbons are converting into saturated hydrocarbons. This type of reactions can be called as addition of reactions. This addition of reactions must be presence of a catalyst will be follows. So in the chemical properties of carbon and compounds, the fourth type of reaction is a substitution reaction. So substitution means any one element or atom, a group of atoms can replace that element in that molecule. So you can see the definition: an atom or group of atoms in a given compound is replaced by other atoms. It is replaced by other atoms. That we can say as the substitution reactions. In the substitution reactions, alkanes can be involved. Actually, alkanes are less reactive, so that we can say those are the paraffins. Alkanes are less reactive, so we can say as the paraffins. Means no affinity towards the chemical change. These are very less reactive. But in the presence of sunlight, the alkanes will react with the chlorine molecule. They can replace more electronegative element of chlorine can replace that one hydrogen in that methane molecule. It is a continuously replaces all the four hydrogen atoms by the four chlorine atoms. So you can see the reaction: methane, carbon with four hydrogens are reacting with the chlorine in presence of a sunlight. First it is displaces the one hydrogen atom and it is replaced by chlorine. So it is removal of HCl, hydrochloric acid. It is a further continuously reaction. Every time one chlorine atom can replaces the one hydrogen atom. See, CH3Cl converted to CH2Cl2. CH2Cl2 further react with the chlorine CHCl3. The CHCl3 further react, it is changes to CCl4. First actually it is in a CH4. All the hydrogen atoms are replaced by chlorine atoms. So this type of reactions can be called as a substitution reaction. It is in the presence of sunlight only possible.